This is the worked out solution for problem number 35 in section 10, chapter 2, or chapter 10, section 2. It's a system of 4 variables. Step number 1 is to decide which variable that we want to eliminate. So we've got these 4 variables. I just decided I want to do W, and you could decide any variable you want. I noticed that it would be very easy to eliminate W's because I already have 2 equations without a W, and by adding the first and the fourth equation together, that would eliminate a W as well. So that's why I decided to eliminate W. I decided to number the equations so it's easier to talk about them, equation 1, 2, 3, and 4. So to eliminate the W, I'm going to take equation 1 and add it to equation 4, and this is the result. That I call my equation A. I need 2 more equations from this system that do not have a W in them, and since we already have 2 of them, equation 2 does not have a W. I'm going to call that my second equation where I have eliminated the W. And my third equation that I had eliminated the W was equation 3. Again, I just rewrote it because it already was eliminated. So now I have these 3 equations, A, B, and C, none of which have a W. I'm now going to decide from those which variable to eliminate. And again, I look at it and I notice that there's 2 equations, equation A and equation C, are the only 2 that have an X. So I decide that I'm going to eliminate the X. And to do that, I am going to take equation A and subtract 3 times equation C. And so here's where you see that, and the result is negative 5y plus 7z equals 12. I call that equation 1, or equation I. And I need a second equation from this group of 3 that does not have an X. And we notice that equation B already is missing an X, so I'm going to use that. So now I have my 2 equations with only 2 variables. I need to combine them to eliminate a variable, so I decide the variable to eliminate is going to be y. To do that, I'm going to take the first one and add it to 5 times the second one, and I have this, the result being negative 3z equals negative 3, which helps me to solve for my very first variable in that z is positive 1. Now that I have one of the variables solved for, I'm going to go back and substitute it in. So I'm going to substitute it into either equation 1 or 2 here. I like equation 2 better. It doesn't make any difference, but I plug it in and I solve for y, and I have now solved for the second variable. I now have 2 variables that I solved for, and I'm going to plug it into one of these equations, A, B, or C. I just happen to like C, because the main thing is I'm going to be solving for x. If I tried to plug it into equation B, I wouldn't be able to solve for x because it doesn't have an x. What would happen is I would plug it in here and I'd get a true statement, but I wouldn't be able to solve for x. So really, I have to plug it in either to equation A or C, and I like C. So I just plug them both into C. And then I simplify, and now I have solved for the third variable. Once more, I'm going to take these 3 variables that I've solved for. I'm going to take the 1 for the x, the negative 1 for the y, and the 1 for the z, plug it into any one of these equations here, and it won't make any difference except for the fact that I know I'm trying to solve for w. So I have to make sure I pick an equation that has w in it. So that means I'm only going to use either equation 1 or equation 4. I happen to like equation number 4, so I plug them all into equation 4, which allows me to solve for w, and so now I know that w is 2. Now, personally, from everything that I would tell you is that you now need to answer this in an ordered quadruplet. It's got 4 answers, four parts to this answer, and typically your quadruplet should be in alphabetical order, meaning you would answer W, X, Y, and then Z. But I noticed in the back of the book they actually give the solution in the order that you see them appearing in the equation, X, then Y, then Z, then W. So the ordered quadruplet is going to be X, Y, Z, which means the answer is 1, negative 1, 1, and 2. So that's solving a system of 4 variables.